Hello, everybody. This is Stephen Feuerstein, developer advocate for PL SQL Oracle Database, joined by Chris Saxon.
Hi, everyone.
There's Chris. Chris Saxon is a member of the Ask Tom Answer team, as well as a member of my team of developer advocates, and he's here to answer all the questions I can't answer if they spread past my PL SQL expertise. Thank you, Chris.
Lucky me, yep.
Lucky you, that's right. So folks, thanks for joining us. We're going to spend an hour or less, depending on your questions, talking about PL SQL topics. I'm going to start with a presentation, a very short presentation on log errors. It's actually a SQL feature, but it intersects with PL SQL really importantly. And we'll explore it and take your questions on it, and then ask anything else you've got. In terms of our office hours program, it's hosted by Ask Tom. We offer many, many sessions every month from dozens of database experts on a variety of topics. The whole idea is to open a big, wide pipeline of communication between us inside Oracle headquarters, though I'm not really inside Oracle headquarters, and our users to help you be as successful as possible with this amazing Oracle database technology. So thank you for joining us and for watching this video later. Now, in addition to all the great technology we get with Oracle Database, we also offer a lot of free resources to help you be successful with that stuff. So I want to make sure I cover a little bit of that before we dive in. First and foremost, Ask Tom, one of the top go-to places to get your questions answered on Oracle Database. Tom Kite ran the site for 15 years. Chris Saxon and Connor McDonald took over with some assistance from Maria Colgan and other folks at Oracle when Tom Kite retired in 2016. So we're going strong, answering lots of questions, building out an incredible knowledge base. And we added in the last year the Office Hours program again to offer lots of access to our database experts directly. And later on today, for example, you can talk to Dan McGann and Christopher Jones on JavaScript and the Oracle database and looking at some of the new technologies and how we're incorporating them into or making those developers on those languages accessible to Oracle Database. Second of all, still free, Live SQL, 24/7 access to the latest version of Oracle Database, now running Oracle Database 18c, though of course everybody can run Oracle Database 18c since now it's available on XE, our free database platform, released just a couple of weeks ago. So we not only offer a place where you can go and try out SQL and PL SQL, but we also have a code library of scripts. I'll be using those scripts as usual in my presentation today so that you can come along and do the same thing yourself later. Finally, nearest and dearest to my heart, the Dev Gym, offering classes, quizzes, and workouts on Oracle database technologies and others, including Java and Logic. So check it out. You can take daily workouts. You can sign up for a whole variety of classes, including Chris Saxon's Database for Developers classes. In fact, Chris will be starting up a new version of his very popular Database for Developers Foundations class with 14,000 registered students. We'll be starting up the next version of that next week, including live SQL tutorials, beefed up quizzes, check it out, and lots of other resources here, including Python classes, PL SQL, and SQL and database design. So lots of resources for all of you to take advantage of as you explore and learn how to leverage Oracle database technology. Alrighty. So today, we're going to talk about log errors, and I put this under the topic of SQL isn't always all or nothing. Let's take a look. So isn't a non-query DML insert, update, delete, merge statement atomic? Meaning, if I have an update statement that says update last name equal to upper of last name across the employees table, no where clause, that's one statement, one DML statement that will update, in our case, 107 rows. So there's a one-to-many often relationship between statements and rows. Of course, if I'm inserting a single row, it's a one-to-one relationship. But in general, either that statement works or it doesn't, right? So if I do an update across all 107 rows, and at the 106th row something goes wrong, the whole thing is rolled back, no changes. That's the default behavior, and of course, that's almost always what we want. But it turns out that you can actually override that behavior with the log errors clause in your SQL statements, which is what we're going to explore today. And the whole idea then is that it suppresses the error at the row level. So if I've got that massive update, updating 1 million rows, I get through 100,000 of the million rows, and there's an error. Rather than throw away everything that just happened, I can say, hey, save that error information out to a table. Keep on going. And when you're done, I'll take a look and see what went wrong and see what I should do about it. But you should only do this with great care and forethought. As with almost any feature in the database, we've got so much stuff packed into Oracle database. You can't just say, oh, that's shiny and bright. I love that. I'm going to take that and pop it into my database, start using this feature without thinking it through, without talking to your DBAs while there's still DBAs around before they turn into data architects in the cloud. So there are certainly ramifications with anything having to do with non-query DML, transactions, modifications to tables. And in this case, again, you're saying, I don't want that all or nothing atomicity of a statement. I want to bypass or sidestep that rule and apply different rules. So you want to do it with great care. It needs to make sense for your application context. And in general, with this kind of situation, you're mostly talking about some kind of batch process, right? I'm updating a whole lot of rows, inserting a whole lot of rows. And if something goes wrong, maybe it's okay to let the rest slide through and then go back and deal with the results, the consequences. Okay, so I'm going to show you a couple of scripts. We're going to run through examples and all that stuff, the syntax. But first, I thought I'd offer a little quiz. So you can submit your answer in the chat line. And by the way, I should have mentioned before, we've got you all on mute. If you have any questions, any comments, put it in the chat. Chris is watching. I'll be watching as well. We'll pull the questions off of there. And you can also answer the quiz here. So what will be displayed after executing this block? And assume that there's a unique index on last name. Clock is ticking, the minds are thinking. What will be displayed on the page? You can type right into the chat. You could say unhandled exception, you could say nothing, after equals 1000. You pick.
Should we see who's going to be first here?
I guess so. I guess we're going to see who's going to be first.
Oh, Tim Scott's going for 0. Judith's going for 1.
After equals 0, after equals 1. Okay. Those are two pretty good choices. I like it. Like if somebody said after equals my mother, well, that'd be very irrational. Try not to be too irrational in your answers. Got another after equals 0. Okay, so let's take a look, and you guys can continue to explore the code as I'm going through it. And let's turn on my little pen. Okay. So what I'm going to do is first get the count before. How many rows are in the employees table? As I'm sure you all know, the answer is 107. The employee table has 49, I think. And of course, the good old M table has 14. So 107 rows should be coming back there. Whoops. Sorry about that. Okay. Then I'm going to insert a row into the table. Whoops, I'm having problems here. Let's turn my pen back on. I'm going to insert a row into the table. Now, of course, I should have told you there's no row with index with employee ID 10707, but assuming the standard employees table, that should be no problem. So this goes into the database. This goes into the table. And then we try with another one. And lo and behold, we've got the same last name. That's clearly not going to work. So this should raise a dupe valid index error or a -1. So we come down to the exception handler. It traps any error. I get the count in the table now, and I say, what's the difference between the two? And the answer is after equals 1. And the reason and the point I want to make here, and I get rid of that. Sorry, erase. So the reason that is the case is that any DML statements that successfully complete in your session are still there waiting to be committed or rolled back, even if another exception occurs in the SQL layer or wherever else. So just because this insert failed does not cause a rollback on this first insert. So there's one more row in the table inside this exception handler. Now, if the exception came out unhandled through the outermost block, in other words, it came back to say SQL Plus or SQL CL or SQL Developer or your application front end, unhandled, then in almost every case, there's going to be a rollback in your session. So both rows would be rolled back. But within the PL SQL context, within your session, that first row has not been rolled back. And that's always a very important thing to keep in mind when you're looking at any DML related issues. Anything else come up in the chat?
Just Judith pointing out that it depends whether new name not in DB already exists. So, which of course is, as you mentioned.
That's right, that's right. And I should have said not only assume unique index, but nobody in the employees table with either of those first pieces of information. Thank you. Okay, so let's cruise along. So remember, an exception raised in the PL SQL block does not automatically result in a rollback unless it's the outermost block. And you can and should explicitly control transaction management. And this is just a kind of a general reinforcement as we look at log errors in which things can get actually really complicated in terms of you deciding what a transaction is, what you want to fit into that commit, how you want to recover things. Okay. So key log error features. Let's just talk at a high level about log errors. The basic idea is that when you attach log errors to your DML statement, and you're about to see an example, any row-level errors from that statement are written out to a DML table using an autonomous transaction procedure or its equivalent. In other words, we write a row out to this table and we save that row, but it hasn't affected the rest of your transaction in your session. Those are still waiting to be rolled back or committed. No errors raised when the statement is completed. This is one of the most important things to realize. If you put log errors on your statement and you run it, it could be that none of your rows were modified. Errors, it errored out all over the place. But you'll never know in the session, in the block, that called that SQL statement. No errors raised. And this is in comparison to for all with save exceptions, which suppresses errors at the statement level. But as soon as it suppresses at least one statement, when the for all statement completes, then it raises -24,381. So one difference here, no error, there's no indication to you that something went wrong. You have to look in the table. The DBMS error log package is provided to you to create the error logging table. And you can also specify a rejection limit. You can say, you know what, I'm doing this batch job and I've got 1 million rows I'm going to insert. Probably, you know, if I get 2 or 3 or even 100 wrong, that's okay out of 1 million. But if I get more than 1,000 errors, something's wrong with this data, something's wrong with my job, something's wrong, just stop, kill it. So you can decide that.
Okay.
Chris.
Yep, we just got a comment or a question coming in from Dennis. He's like, so what is the SQL % row count attribute? What does that show after a log errors?
So SQL % row count is an attribute that tells you how many rows were modified by the statement that was just executed. And you know what, Dennis? I actually have never checked. I believe, and we will go and do this in Live SQL, I believe, maybe I have checked. Anyway, we'll take a look at the script, but it should tell you how many rows were modified, the actual rows modified. So in other words, it should reflect the total rows that could have been modified minus any errored out statements. But we'll check. And in fact, let's go right over to Live SQL and try it out. So when you come back later, go to Live SQL. You can search for suppressed DML errors. You can look for log errors. Let's go look. So here I am. I'm going to type in suppress. That should get me there pretty quick. Suppress DML errors at the row level with log errors. Okay. Now again, the reason I like to use Live SQL is that this way you can come back at any point later and try this out yourself, run it, and go through all the examples. I put in a lot of comments in the yellow boxes explaining what's going on in each statement. So hopefully this will all make sense now, and it'll make sense later. Let's take a look. So first of all, I'm going to create a table called employees as a copy from the HR schema. When you first log into Live SQL, your schema is empty. We assign one to you, we create it for you, but it's empty. So I'm going to grab stuff over from the employees table in HR. Then I'm going to say, hey, create an error log table for this table. So this is the DML table. Here's my DBMS error log package. And this will create a table called error$_employees. And you might say, of course, well, what if my table has 30 characters long and I'm going to put error$ in front of it? Then it's going to be more than 30 and it's going to blow up. And not anymore. As of 12.2, you can make them as long as you want. Prior to that, if you did have a very long table name, you can override the default error log, and you still can, through the create error log procedure call. But that's the simplest and easiest format. Okay, then if you take a look at the error$ employees table, what you'll see is that it always creates a standard persistent database table in your schema with these 5 columns. So basically, what's the error number, what's the error message, what's the row ID, what's the operation type, UID, and what's the error tag information that you can add along into the row. And then for every column that is varchar2 compatible, in other words, integer, date, string, etc., it'll create a varchar2 4000 column with the same name. And it'll put the information it'll take the data from that row that failed into these columns at the time the error occurs. So we create that table, or Oracle created it for us. Now let's take a look at the all or nothing situation. In other words, if I don't have log errors. So let's suppose it's a year from now, and Oracle Autonomous Database has exploded onto the world, and everybody's using it. Everybody's on the Oracle Cloud Services, And Larry says, you know what, guys, you deserve a really big bonus. You did an amazing job, Oracle Database team. So I'm going to multiply all of your salaries times 200. That's right. It's going to be a great day at Oracle, a banner day. So what I'm going to do is see if I can accomplish this great and amazing feat. First of all, I'm going to see how many people already are making more than $24,000 per minute, or whatever it is, as salary. And I'll show that count. Then I'm going to say, all right, everybody, it's time to get a lot of money in your pockets. Then I'm going to see how many people are making more than 24,000 after the update, either in the executable section, in other words, no error, or if something went wrong, how many are making that much now in the exception section. And when I run this code, what I find is that before, nobody was making that much money. And afterwards, here's the format error stack, the error message. The value was too large. One of the rows, so I was doing the updates, maybe on the 1st or the 7th or the 27th, it tried to do an update and multiply that salary by 200. It got too big for the column and it failed. And then afterwards, if I come down to the exception section, I find that no rows were modified. So it all rolled back. That's the all or nothing form, default form of SQL. Okay, so now I'm going to go back to that same script and make a couple of changes. First of all, I'm going to add log errors, reject limit, unlimited. And Dennis, there we go. Afterwards, what's the SQL % row count? I guess I should have known the answer because I wrote this code. So I'm going to say update the employees and ignore any errors. In other words, reject limit unlimited. You can have as many errors as you want. I don't care. Keep on going all the way through. And then when you're done, show how many rows were modified, how many people are now making a whole gazillion boatloads of money, and how many are in the table. Okay, and then I'm going to roll back for whatever reason. Notice also, I took out the exception section. There's no exception handler at all. And yet, when I run this code, look at the difference in behavior. Before, nobody was making that much money. Afterwards, 49 people had rows modified. And out of 107, 49 rows were modified. And in fact, 49 people are now making a lot more money than they did before. So that's the fundamental difference with log errors. With all or nothing, either they all work or they don't. So if anything went wrong, I end up in a situation where my table is back where it was before. But with log errors, I suppress each of those failures, and it stays inside the SQL engine, keeps doing its job, and then returns control back. And then I have to say, let's check the error logs table. So next step, how many rows in my error $employees table? 58. 58 plus 49, 107. So there's the total number of rows in the table, since I had no where clause. And then check the error log table. So I'm going to look at the error message, the row ID, last name, just to give you a sense of what's available there. And you can see that in this case, all the errors were the same. That's, of course, not always going to be the case. There's the row ID. There's the last name of the person who had the problem, who couldn't get their big increase. Then I'm going to clean up the error log table. Now, of course, there are lots of things to think. I'm sure if you haven't looked at log errors before, and I know a number of you have, then you'll realize that instantly you're confronted with a number of issues. For example, no error is raised. It's totally on me, the developer, if I'm going to use log errors, to write the code to check afterwards. I could say, whatever. If I didn't update 5 rows or I did update 100 rows, whatever the case is, that's the way it was. You could say that, but I don't think you'd want to do that in production. The other thing is you want to clean up the error log table after you're done analyzing it or moving that data into your actual application error log. Otherwise, you won't know whether or not the rows in that table came from your run or not because of some issues with the error log table we'll get back to in a moment. And here's an example of specifying that limit on rejection. So now I'm going to say update employees. I'm going to try to make their name the first name really long. And I'm going to say, look, limit of 10. If more than 10 failures occur, just stop. That's it. Something's wrong. And when I run this, notice that it did stop with an error. So the log errors reject limit 10 said that when I hit the actual limit and it was 11, when I get to the 11th error, then it stops. It does raise that error. So your block will be terminated with an error. And then you can go through the same analysis as before. Okay, so that's the basic idea behind log errors. Do we have any questions from that, Chris?
No, I don't see any other errors. Dennis is glad we've cleared up the SQL log SQL row type thing, but I don't see any other questions coming in.
Okay. So now let's talk about some log errors. Gotchas.
Just one thing. So does it write to the log table in the event that the reject limit is reached?
Yes. So as far as I know, yes, that's what we just saw. In fact, so in the case of the last step, I said that my reject limit was 10. What that really means is that on the 11th error, and notice there are 11 rows in the error $employees table. So the 11th, the limit plus 1 is encountered. It's written out to the log table, and then the SQL statement is terminated.
Okay, and we got another one coming in, slightly interesting one. Why would you use delete from error $ rather than a truncate?
Why would you use delete from instead of truncate? That's a good question. I don't have a good answer off the top of my head. One issue is that truncate is a DDL statement as opposed to a DML statement. It'll be faster. I doubt that, and Chris, you chime in as well, but I doubt it will be much of an issue in terms of performance. Again, usually I'm hoping that when you're using log errors, and we're going to come back to this in the question section, if you're updating 1 million rows, let's say, or deleting 1 million rows, and you get 900,000 errors out of that 1 million rows, that's not a good use of log errors. For one thing, you're going to, as we'll explore, see a bunch of overhead. It's going to slow things down. So you're probably going to want to use log errors when a relatively small number of errors are expected out of the total number of rows that are being modified.
Yeah. So I think that's a good point. And as Tim Scott's saying, which I agree with, you may not be the only transaction erroring. So if 2 people are trying to log errors at the same time, if you truncate, then you're potentially wiping out the other person's errors, which is, not great.
That is a great point. That's right. So this is a single table that's shared by everybody who's writing to that table. It's the error log table for that DML table employees. So it could be that we have 25 different sessions that are all writing into that table via their problems with their SQL. Okay.
And we're asking as well, who owns the error $? So I think this is something you're going to cover in a minute, isn't it?
I don't get into a lot of detail on that, but let's just go ahead over to the DBMS error log package. Sure, we'll go to the 10.2. It's right there.
It's great how we have the most recent stuff at the top there, isn't it?
I'm sorry, Docs. I think that was me, actually.
Oh, okay.
I'm sorry, Docs team. I should be showing them 12.2, but this hasn't changed. So here we go. When you create the error log table, you can specify the name. You specify you have to specify the DML table name. Then you specify the log table name if you want to override it from the default. And then you can specify the owner and the table space as well. So if you have the privileges to create the table in some other schema, you can certainly do that. Skip unsupported means that if you have columns that cannot be converted, remember I said that, let's say last name and first name and salary can all be implicitly converted to varchar2. So those are supported types. Types that cannot be supported, for example, blobs. If you have a table that has a blob column and you don't say skip supported is true, then the request to create the error log table will fail. So those are the details on this procedure. I don't think anything's changed since 10G, and this is the only subprogram in the package so far. Okay. So some gotchas. It's funny, I've talked about log errors for a while, and for a long time I was not with Oracle. I came back in 2014. And so I would develop these jokes about Oracle functionality that I have to, be a little bit more circumspect now that I'm back at Oracle, but I think this is still quite okay to say. So log errors to me is a great example of one of those features where it seems like they had a really great example, a really great idea to offer this functionality, and it's really deep down in the SQL engine. There's no way that you could implement anything like this. It's got to come from us, from Oracle. So they had a great idea, and they implemented it, I think, really nicely, except that they didn't quite finish. They left some things out. And so let's talk about some of the gaps in terms of this functionality and what you can do about it. So first of all, the error table is missing some really useful information. For example, when did the error occur? There's actually not a timestamp on the row going into the log errors table. Well, that seems kind of weird, right? Where did it happen in my code? For example, you can call DBMS utility format call stack or something from the util call stack package. and find out the execution stack that got you to that point in your code, and who did it. What was the name of the schema, the user who actually tried to execute that DML? So that's really unfortunate because as someone else was mentioning in terms of the truncate versus delete, we could have 5 different processes all writing log errors into that log. How do you know which one was yours? How do you know it wasn't yesterday versus today? All that kind of things. So here's the great news. It's just a persistent database table. Yes, you should call dbms error log create error log create log table, create error log to create that persistent database table. But if you wanted to, you could literally say create table. You could write your own create table statement, and as long as it's got these 5 columns in it, doesn't have to have anything else. As long as it has those 5 columns in it, it's a valid target for the log errors process. So you could create the table yourself, but more importantly, you can have Oracle create it for you, and then you can alter the table to fix these gaps. So, and I'll show you, I've got a helper package in LiveSQL, and I'll show you exactly how you can do that. You can use my code to do it. Here's another gotcha. So let's say that HR owns the employees table, HR owns the log table, and then you grant insert on the employees table to Scott. Scott tries to do an insert, tries to do an update, and there are some errors with log errors. And then Oracle tries to write into the log errors table, but Scott doesn't have insert privileges on the log errors table, and you get a runtime table of view does not exist. So that can be really weird, right? You've got this code, your log table is hidden away. You don't see it in your application code. And you're getting this table of view does not exist error. And we're not going to tell you what the table name was because that's a security violation. We don't want to give out that information. So but you've got access to all these tables. So that's the problem. You need to make sure that the log errors table has, or the users who are going to write to it have the privilege to do that as well. Now, Chris, before I move on to my helper package, do you have any other gotchas or thoughts about log errors that people should be aware of?
I think that covers most of the things people should know of. Like you say, it's just being aware of you don't get the exception is probably the biggest thing. So everything can look like it worked when in fact it's failed. So you've got to have your extra code to pick up the log errors or check that code, what's in there. And I think having that extra logging information is really useful at that point, because if you're in a multi-user environment, just the fact there's something in there, well, it doesn't necessarily mean it was your statement that put it in there.
It's not very actionable for you to try to do something with. That's right.
Exactly.
Okay, let's go over to back to LiveSQL. And now instead we'll take a look at, we'll just search for helper. And the reason I thought I would do that is you might, and in general, when you're searching through LiveSQL, I've created a number of what I call helper packages. So there's a util call stack helper package, there's a PL scope helper package, and there's a helper package for log errors. So let's click into that one. So what I've done here is basically said, look, we need to make the log errors utility. The log errors utility itself is fantastic, but we need to provide a little bit more help to make it really useful to us. So what I did was, wait a minute. Did this get overwritten with the wrong? No, there it is. I'm actually not sure why all that stuff is there. I'll have to go back and look at the script. In any case, package specification, dbms error log helper. So the basic idea here is that instead of calling dbms error log, create error log procedure, you will not call that yourself. You will call create objects. And notice the same parameter set is here. So that's for dbms error log. And then there are some other things as well. So for example, you can provide we'll actually generate a package for you to help you manage this table. Every table has a different name. Why not have a different API to it? And so this will actually generate the package and return the code if you want it that way. And a few different overloadings of that. Okay, then inside the package, without going into too many details, the basic idea is that this is a great example of dynamic PL SQL execution and how you can build some really cool utilities with it. So here's create error log. And that just encapsulates my call to dbms create error log and traps the table if it already exists, if I do say that it's okay to overwrite. Okay, so I've created my table. And that's all you get if you use the built-in package. But then I say, well, you know what? I'd really like to know who did it. So alter table, add a column. Alter table, add when it was done. Alter table, add who did it. And, oh, this is the call stack, right? So this is the call stack. And then create a trigger before insert or update on this table. Not sure why I did update. We really shouldn't be doing any updates to this table, but okay. So then set the user, set the date, set the call stack. And obviously, if you like this idea, but you want to change, for example, how the user is assigned, you want to use syscontext instead, download this package and use it to your heart's content. So that's the way you can modify your existing table and kind of fill out the gaps in functionality that we somehow didn't get around to doing. And then I have some code to generate a package. We'll not go into all the details around this, but it basically gives you an API to clear out your error log, creates new types based around that type of the table, and then a function to get the contents. So hopefully that will make it easier to do. Okay. So I had just one question on log errors, and hopefully you'll have more. You have questions about PL SQL and SQL beyond that. So the question is, should I worry about the performance overhead of log errors? Is this going to be a problem? Chris, is this going to be a problem?
Well, I think it's an interesting question, because the question you have back is, well, what would you do instead? You know, you're doing this because you want a process to actually complete, regardless of whether there was one or two failures in it. Well, what's your alternative? And you know, so you're saying, is this going to be a performance overhead? Well, what are you comparing that to? And is that actually, you know, going to be any quicker? What your alternative?
That's a good point. So what is your alternative? So, you know, similar to, I think, a lot of other pieces of functionality, the first question is, well, the first comment would be, do you really want to do this? Do you really need to do this? This is definitely one of those need to do's, right? It's you're bypassing the default SQL functionality. You only want to do it if there's a really strong need to do so. And in that case, you might have to say, well, the performance is what it is. Now, in terms of the performance, I actually don't know for sure if the implementation of this approach is that it has an autonomous procedure in PL SQL. So let's see, just to make sure you guys know what I'm talking about there. Let's go back to Live SQL. And let's search on autonomous. So just to make sure you know what I'm talking about, in terms of an autonomous transaction procedure, the basic idea is that you have a procedure that says Pragma autonomous transaction. And then when you insert into a table, and this is the typical application is a log table, some kind of error log, then you can commit your changes. In fact, you must commit or roll back your changes before this procedure terminates, and none of the changes in the rest of the session are modified. So again, it writes it out to this table, it saves it, but your changes are not yet committed. It could be that it's actually implemented as a PL SQL procedure, in which case there would be a context switch. Every time you hit an error, it's a context switch to the PL SQL engine to do an insert into the table. It could be that it's not implemented that way. There might still be some level of context switching. But the bottom line is that, of course, there is going to be overhead. And I think the real thing there is, besides saying, I really want this functionality, I really could use this functionality for this particular process, then again, the question I think that you should ask yourselves is, what percentage of my rows do I expect to cause errors? Because if I do have 1 million rows and 900,000 of them are going to error out, you're going to look at a pretty significant overhead and slowdown as a result of using log errors. And you might say, well, again, that's it. That's all there is to say about it. That's the way it is. Or you could say, wow, you know, maybe a single update statement that covers 1 million rows in which 900,000 of them error out routinely is not the way to go. Maybe I need to rethink my whole process around which I'm doing this update. Hopefully that helps.
Yeah. So there's quite a few questions coming in the chat about this. So first up, one of the things Dennis says is that one of the things you can do is prepare your data ahead of time so that you're not processing any invalid data. And I think it's a good point. You know, if you've got things like, if you suspect that things won't convert to dates, for example. Quite often you get text files, you need to load them in, and they get dates that are not real dates and things like that. Well, you could filter those out before you even do your insert. So you've got to look at the performance there. I'm not sure if you've got anything to add there, Stephen, or?
Yeah, I think that's a great point. What I would add is that in terms of advanced processing of the data, so that got me thinking about bulk collect and for all. So you can actually bulk collect your data into a set of arrays that you have to then iterate through to make your changes. And here's the thing I wanted to make sure you know about. When you use for all, which is a bulk DML push back from PL/SQL to SQL, you can put log errors on the DML statement in a for all. So you can get the best of both worlds. I mean, let's say you've got 1 million rows of data that you need to update. So Dennis is saying, look, basically validate that data in advance. I guess there are a number of ways to do that. I thought about moving it into a collection and validating it. Anyway, but if you do that, then you're going to probably be switching over to for all to do the pushback. Yeah, that's what I got.
Yeah, so that's good. You're just pointing out that Adrian Billington has quite a detailed article actually comparing the performance of log errors in different scenarios for using it. So many of you probably seen the oracle-developer.net site. He's got an article there, which...
Let's go over and check it out. Yes, so I think everybody at this point knows about Oracle Base, Tim Hall's fantastic website with so many articles for developers and anybody doing anything with Oracle database. Oracle-developer.net is probably less known, partly because Adrian Billington, who's a really sharp guy, stopped at 11G. I think he had 1 or 2 more kids and said, I don't have any time for this. But if he's covered it, you will find it's a pretty amazing resource. So let's see, log error. So yeah, so it's another resource. I don't know if I put that on this session, in which case I will certainly add it. Let's see. So just so you know, when you're Ask Tom page, if you click on resources, you'll find a list of links that are in some cases are quite generic, but on the top you'll find the one specific to the topic at hand, and there you go. I knew about that article all the time. And I'm not sure that this is the one that actually does the comparison of performance, but there you go. That's great. Thanks for the reminder, Judith. Okay, what else have we got?
So a bit of a sidestepping question is Michael's asking, can you combine autonomous transaction and the UDF pragmas? So I guess, Michael, are you asking can you use other pragmas besides autonomous transaction at the same time?
Let's see.
Yes. Yes.
Do you want to take that, Chris?
Yeah, I mean, I'm not aware of any conflicts from various pragmas you can have. You're thinking about the performance impact of. Yeah, I think you're gonna have to explain a bit more, Michael, about where you're going with that one in terms of the performance impact.
Yeah, I'm not quite sure. Certainly, so the UDF pragma, the idea behind UDF, I'll pull up an example. So the idea behind the UDF pragma is that in 12.1, you can literally add this pragma to your function, only for functions, called UDF, and that says to the compiler, hey, hi, I'm a user-defined function, and what that means is I'm a user-defined function in SQL. So in the SQL engine, you're going to call my function. And what this is telling the compiler to do is, at compile time, do some of the setup work that's needed to move between PL/SQL and SQL engines, that context switch. So some of the runtime context switch activity is moved to the compile time point, so that when you're actually doing the context switch for this function in SQL, the overhead is reduced. Now, so that's what UDF is about. And then the question was the intersection of that functionality with autonomous transactions. So you can certainly also make a function an autonomous transaction and then do DML and commit and all sorts of things in it. It's something you, again, want to do with a lot of care and wariness, because you need to worry about read consistency of your data, among other things, certainly performance. But if you're doing some logging, I suppose, inside the function call, and you want to just write out a row and save it without committing or being allowed to run that function from within SQL, You can certainly combine them. I don't see any issues.
Yeah, I don't see any issues either, particularly. So Sven Voll is saying, is the UDF Pragma is overrated for its performance impact for real world work? I think.
Go ahead.
Yeah, I think there's been a lot of debate about this feature and when it's useful, when it's not useful. And I think it's always comes back to, if you think you need it, test and validate what benefit you're going to get.
Yeah, and I think the issue there, that's a good point, Sven, and I think that you and others have documented. I think that Bryn Llewellyn, who's the PL/SQL product manager, has also documented a lot of this in his performance testing presentations. It depends on the data type. It depends maybe even on the sizes of the values. I think it's mostly the data types, numbers and dates and strings. So yeah, so again, hopefully we'll enhance it over time. I know that they're looking at extending the power of UDF or the impact of UDF to a wider range of scenarios, and hopefully we'll just cover more and more over time. But it's not a silver bullet. It's more like, in terms of using UDF, even if you don't expect to get a lot of benefit out of it now, if you're writing a function that almost always will be called from SQL, put the pragma there, because you're giving that information to the compiler. And today, it might say, ooh, for this function, you're going to see a nice boost. Oh, for those functions, not so much. But then in 19C and 20C, as we fill out the gaps, suddenly, because you've put the pragma there because it's accurate, that is a function only being called in SQL or almost exclusively, you'll start to see benefits accruing in the application performance. As Dennis points out, UDF shines because it's a declarative feature. Exactly the point that I was making, but you did it so much more concisely. Almost everybody makes some points more concisely than I do. So you're simply declaring to the compiler, hey, here's some additional information for you. If you can use it, great. If not, no harm done, because I know it's true. Just like saying, declaring a function to be deterministic. If you know the function is deterministic, it really might not buy you much. You're not using it in a function-based index. Its chance of doing caching within a SQL statement is minimal, but still, you're just providing more information to the compiler, and also to people coming along later. You're self-documenting in the code. This is how it's intended to be used. Okay. Other questions?
I haven't seen any other questions come in so far.
Okay. Let's see. And I'm going to give you the floor, Chris. And if you want to, you could spend a couple minutes talking about Open World, if you want your experience there and how things went. And now here's a comment from Dennis. Sorry,
Yeah.
cut you off.
Yeah, go on. It says a big comment. Yeah, go on.
One of the greatest use cases of log errors. Here, I'll put myself on the screen. One of the greatest use cases of log errors feature, which I had my experience, was when we needed to migrate loads of data from one database instance to the other. It implied many rows and many tables, and it was unaffordable to disable or drop all the integrity constraints. And for this, we used log errors feature. So most of the data was migrated. The problematic data was caught in the error table. And then afterwards, they could start working out the problems from the error table and figure out what they wanted to do with that data. Great point. And again, so in your piece of code, you could have run the DML statement with log errors, and afterwards you check, and yes, there is some data in the log errors table. You can actually run through, you can have a cursor for loop going through that table and saying, well, if the error code is equal to X, Y, Z, I might be able to recover it. So then I try to do a very specific update with a change to the data. But if not, I write it to my actual application error log, and then I can delete the error log table, the DML error log table. And here's Sven asking, do we have an example for the error log errors clause where we add a comment to the update so that we know which update produced the error? Using the tag column. You know what? I don't think I've ever used the tag column, Chris. How about you?
I have never used that either. So.
Well, wait a minute. I invite you to share the webinar with me. You should like this.
So all the bits that you haven't done, I'm supposed to fill in.
Yes, that's correct.
All right, I'll remember next time.
I guess so. And I'm going to take advantage of my powerful editing capabilities, and I'll just edit the script. I'll fix it later. Right here. Okay, save that. Run my script.
There we go. That looks more promising.
Yep. There's the logging. But now, so that's how you do it. There's the syntax. But I think what you'd also like to know as well, what do I see in the table, right? So let's go ahead and edit again. Right here. I think that was the column name. I hope so.
We'll find out, won't we?
And I think also, I'm assuming, as you can see, folks, you know, I know pretty well what I've tried out and used. So the question is, what can we put in here besides something like my bad? Let's try putting in. Oh, let's go crazy. The thing is, if it's a column name, you've already got the columns. Okay, I'll leave it. And there's the tag. So that's how you put the information in. I assume we can put column names in there and maybe even function calls, but I haven't done that myself yet. So let's see if we've got other questions while I play around with this, and I suppose you can check right now.
No, not.
Or Chris, if you want to make some comments.
Yeah, I'm not seeing any other questions coming in. I guess you could do things like put in the transaction ID or maybe session ID, things like that. Potentially useful to help pull out or debug why or how it's gone wrong. Oren's come in with an anecdote. Log errors is a mechanism used under the hood to implement the skip constraint errors option of data pump import. You like the fact that Oracle use their own features and internally? Yes, that's good. It is great when we use our own technology, isn't it?
So here's an example of that's great, Oren, thanks so much, of putting this function called this expression, and that works as well. And there's the substringing.
Yes.
So it looks like anything you can execute in a SQL statement at that point is something you can run here. All right. Other questions? Doc says simple expressions are allowed. Well, we wouldn't want anything to get complicated. At least it doesn't say static expressions. That'd be really bad. Okay. Other questions, not just about log errors, but anything in PL SQL or SQL? Be happy to answer them while we've got me and Chris on the phone. If not, make sure to check out our classes. Check out our many workouts and, of course, our weekly tournament quizzes. We just added, in fact, about 6 weeks ago, we've added a weekly Java quiz as well. So we've got a Java champion, Rafael Del Nero, writing most of the quizzes. In this case, Vivek did one for this week. But you can explore the non-database side of Oracle technologies as well, and we'll be adding more and more over time to the Dev Gym. All right, well, thanks for joining us for almost an hour. Feel free to come back here within the next day or so, and you'll see the video recording. Also, we'd very much appreciate it if you come back to this page for one of the past sessions, and you can give us feedback on the session. For example, you can say it was really amazing. How can we do better next time? What topics would you like us to cover? And then we'll take that information and help us tune up this program. Make sure you sign up for other office hours programs and make the most of everything that this database team has to offer you for free.